Good day, guys. Welcome back to my YouTube channel on Sagacious Learners. So, in this video, we're going to be talking about current electricity. So, what is current electricity? Electric current is defined as the rate or flow of charge along a conductor. So, electric current I is given as quantity of charge over time. So quantity of charge, we can also represent quantity of charge as Q is equals to IT, making Q the source of formula. So quantity of charge is current times time in seconds. That is, current is equals to quantity of charge over time. The unit of electric current is in amperes. So current is represented in amperes, while quantity of current or quantity of charge is represented in coulombs. So this is how this works. Look at this question. For example, they ask us to calculate the quantity of charge flowing through a conductor if the current of 10 amperes passes through the conductor for 10 seconds. So recalling our formula, I is equals to Q over time. So from the question, they say we should calculate the quantity of charge. So to calculate the quantity of charge, Q is equals to IT. So since they give us our current to be 10 and they give us our time to be 10 seconds, if that they give us this 10 seconds in minutes, we're going to just convert the 10 minutes to 10 seconds. But since our time is in seconds, we're going to leave it like that as well. So quantity of charge is equal to 10 times 10, which is what? 100 coulombs. Recall that I said quantity of charge is represented in coulombs. So let's talk about Ohm's law. So what is Ohm's law, or what is Ohm's law trying to say or tell us? So Ohm's law states that the current flowing through a metallic conductor is directly proportional to the potential difference across its ends, provided that the temperature and other physical conditions of the conductor are kept constant. So Ohm's law, the voltage is directly proportional to the current. So we're going to introduce our constants. So let's represent this law with formulas. So this law states that voltage V is directly proportional to what? Current. As you can see, so introducing our constants, which is V is now equals to I over R. So R is our constant, and this R is known as the what? The resistance, and is measured in ohms. While voltage, which is known as the potential difference, is the volts, and it is measured in the potential difference, and it is measured in volts. While the current is measured in amperes. So let's talk about parallel and series arrangements of resistors and cell in an electric circuit. So first, let's talk about resistors in series. So what is resistors in series? Or if you're talking about resistors in series, what comes into your mind? So the combined total equivalent of effective resistance for resistors connected in series as shown above is R equals to resistor 1, which is this, and resistor 2 and resistor 3. This is the first resistor, this is the second, and this is the third. So 4 resistors which are arranged in series. So how will you know resistors which are arranged in series, and how will you know resistors which are arranged in parallel? So resistors which are arranged in series has only one way in which they can receive currents. As you can see, they are arranged in a way they can receive currents in one direction. So when we reach to the parallel side, you're going to see that the parallel can receive currents through many directions and through many ways. So, what are the characteristics of series or resistors which are arranged in series? First, the same current passes through each resistor. So these points are very important. They're up to four. They are very important because you're going to applying it when solving calculation. The same current passes through each resistor. One. Two, the potential difference across each resistor depend on the value of its resistance, which means resistors which are arranged in series, the potential difference is not the same in each resistor, which means the total voltage is equals to V1 plus V2 plus V3 plus Vn. So they are not the same. The potential difference V across the whole resist connection is equal to the sum of the total voltage. So note that point because it is very important to know. The individual potential difference across each resistor is equal to V1 plus V2 plus V3. The fourth point to know is the total resistance R is the sum of the individual resistance is equals to R1 plus R2 plus R3, telling you that the total or the effective resistance of the circuit is equivalent or is the sum of the individual resistor or resistance in that circuit. I hope you understood what I just said. So let's talk about resistors in parallel. So how will you know resistors in parallel is when they have too many ways of receiving currents. So look at this one now, this diagram here. This diagram here, we have R1 can receive currents through this direction, R3 can receive current through this direction and also through this direction, and R2 can also receive currents through this direction and also through this direction. So this is how you know the difference between parallel and series. So let's talk about some things about the parallel resistors. So the combined total equivalent or effective resistance for resistors which are connected in parallel is 1 over R, which is equals to 1 over R1 plus 1 over R2 plus 1 over R3. But in our series, the total resistance R is equals to R1 plus R2 plus R3. But it's not so in parallel. So the formula for calculating the effective resistance in parallel is this, is equals to 1 over R plus 1 over R1 plus R1 1 over R2 plus 1 over R3. So if you go ahead and make this the subject of formula, you are going to have this. If you make the effective resistance, which is R, the subject of formula, you are going to have this. So let's try making it the series of formula. So we have 1 over R is equals to 1 over R1 plus 1 over R2 plus 1 over R3. So therefore 1 over R1 is equals to the we are going to take, in order to add a fraction, we are going to take the denominator. So taking the denominator, we now have R1, R2, R3. So R1, we cancel R1, leaving us with R2 and R3. So we're going to have R2 plus R2, R3 plus R2, we cancel R2, leaving us with R1 and R3. So we're going to have R1 plus R3. So R3 we can, so we can just go ahead and make R the source of formula. So taking the inverse of this equation, we now have that R R is equals to R1, R2, R3 all over R2, R3 plus R1, R2 plus R1, R2. This is 3. This is how it works. Let's talk about their characteristics. So, 1. The potential difference across each resistor is the same and is equal to the potential difference across the whole connection. Recall that in series, the potential difference is not the same. The potential difference in series is V is equals to V1 plus V2 plus V3. But now they're telling us the potential difference for parallel is equals to V1, which is equals to V2, which is equals to V3, and also equals to V. So which means the potential difference is equal in all the connection and in their individual connection. They are all the same in the circuit. So 2, the total current is equal to the sum of the currents flowing through each resistor. Why in the series we have that our total current is I, which is equal to I1, which is equal to I2, and the rest. But now they're telling us the total current is the sum of the individual currents, which means the current in each resistor is different from the total currents. And to find the effective or the total current, we have to add all the current, which is this equation here. So 3, the combination resistance is always less than the least individual resistance. So cell in series. For a cell connected in series, total EMF E is equals to E1 plus E2 plus E3, and the total internal resistance is equals to R1 plus R2 plus R3. So these are some basic things you should know for our calculation in circuits. So cells in parallel. For cells connected in parallel, total EMF is E1, which is equals to E1, which is equals to E2, and which is equals to E3. But in series, as you can see, the total E or the EMF is the individual EMF in the circuit, but while in parallel, total E is equals to the individual EMF in the circuit. So while the total internal resistance is equals to 1 over R, which is equals to 1 over R1 plus 1 over R2 plus 1 over R3. While in series, we have our total resistance to be the addition or the sum of the individual resistance in the circuit. So these are some important information you should know in order for us to dive into the almighty calculation behind this topic. So let's start. So the first question is, what is the effective resistance of the circuit below? So if they say effective resistance, they are trying to tell us that we should calculate the total R. So to do this, you can see we have the combination of, in this circuit we have the combination of parallel connection and series connection. So from here is series, why from here is connected in parallel. So how are we going to do it? How are we going to solve for it? First, our first progress, or the first thing we should do, is to convert this one that is connected to parallel into series. So all of them can be connected into series so that we can solve in series. To do this, let's bring out our formula. So our formula, we have 4 resistors or resistance which are connected in parallel. We have that R, recall our formula. 1 over r is equals to 1 over r1 plus 1 over r2. So what is 1 and what is 1 over r1? So 1 over r is equals to, let's take 2 to be r1, but you can take any one as your r1 and r2 here. So doing this, you have our 1 over 2 to be r1, and we have our 1 over 4 to be our r2. So 1 over r is now equals to, what is the LCM of 4 and 2? So the LCM of 4 and 2 is 4. So 2 into 4 is 2. So 2 times 1 is 2, plus 4 into 4 is 1. So for those that doesn't know fraction, just use your calculator and do it. 1 over 2 plus 1 over 4, add it and cross multiply. But if you can solve for fraction, that is good. So 2 plus 1 is 3. We now have 1 over r is equals to 2 plus 1 is 3 over 4. So therefore, we now have r is equals to what? 4 over 3. So since r is now equals to 4 over 3 as our parallel, so we are going to add it to our series. And in our series, we have 5 and 3. Since we have 5 and 10 in our series, what we're going to do is to add it up. So connection in series is written as r1 plus r2 plus r3 plus rn. So n can be any alphabet in alphabetical order or in numerical order. So r is now equal to our r1. So first, let's redraw these circuits. In redrawing these circuits, our r1 will become 5, our r2 will become 10, and our r3 will now become 4 over 3, because this is now in series, because we have do it in a way so that we can now solve it in series. So this being in series, we now have 5, 10, and 4 over 3. So since we now have our 5, 10, and 4 over 3, so 5 plus 10 is equals to 15. So 15 plus 4 over 3. So what is, so 4 over 3 is 1.33. So 4 over 3 plus 15 will now give us 16.33. So our answer is 16.33. So let's go for more calculations under this topic. So look at this one here now. I have the total resistance measured at PQ in the diagram above is. So they are asking us, what is the total resistance? So to calculate our total resistance, we have to first, we have parallel and series connection here. So what we are going to do is to convert sum to series and convert sum to parallel. If you see in this diagram, we have 2, 2, and 2, and these are connected in series. This one, and this one are connected in series. Why? Because they only have one way of receiving a connection. So we're going to convert them. So first, we're going to convert this into series. These 2, 2, and 2. So we now have 2 plus 2 plus 2. This is now equals to 6 ohms. So we're going to redraw this diagram. So redrawing this diagram, we have already our 1 ohms resistor. We have our 3 ohms. We have our 1 ohms, and we have our Q. And since we have already add all this, we now have our 6 ohms, because adding 2, 2, 2, it will give you 6. So 3 is now in parallel because it can receive current from many source from this direction, and also from this direction and from this direction. So since it's in parallel with 6 ohm resistor, we're going to convert it into series so we can add it with the 2 remaining resistors. So converting this to series, we now have 1 over R is equals to 1 over 3 plus 1 over 6. So 1 over R is now equals to, what is the LCM of 6 and 3? The LCM of 6 and 3 is 6, and 3 divided by 6 is 2. 2 times 1 is 2, plus 6 divided by 6 is 1. So here we now have 1 over R is now equals to all over 6, 3. So cross multiplying, we now have 3 times R, we now have 3R is equals to 6. Taking R and taking 3. So we now have R is equals to 2 ohms. So we're going to further redraw this diagram. So to redraw this diagram, since we have our 2 ohms, we are going to redraw this diagram in a way so that we can add it in series. So redrawing this diagram, we have our 1 ohms, we have our, there is no more 3 ohms, there will now be what, 2 ohms, because we have converted it to series in a way we can add it to others. So here we now have 1 ohms. So as you can see, this is connected in series 1, 1 and 2 because it's only have one way of receiving current. So 1 plus 1, resistors which are connected in series is R1 plus R2 plus R3. So this will now become 1 plus 1 plus 2. We now have 1 plus 1 is 2 and 2 plus 2 is 4. So our answer is 4. So the answer to this question is C. Let's solve more. The sum of the currents I1 and I2 in the figure below is, so this is the question. They ask us to calculate the sum of the currents. First, we have our I1 and we have our I2. So they ask us to calculate the sum of I1 and I2. So the sum of I1 and I2 is with this formula, I1 plus I2. So they can also ask this question as calculate the effective current in the circuit. Have that in mind. So first, to calculate for I1 or to calculate for I2, we recall our Ohm's law, which Ohm's law states that V is equals to IR. So for the first circuit in this diagram, the first circuit there, we have our voltage to be 12. We have our current, which we are looking for, multiplied by, we have our resistance, which is 10 ohms. So I2 is equals to 12 divided by 10 is equals to 1.2 amperes. It's measured in amperes. So what of I1? How are we going to calculate for I1? To calculate for I1, we have to do something. So to calculate for I1, we are going to say, since we have 2 resistors which are connected or supply a current, we can now say I1 is equals to V, which is equals IR, but we have 2 resistors, so we are going to use the effective resistance. To calculate the effective resistance, since these 2 resistors are connected in series, we're going to just add both of them. So adding both of them, we now have 5 plus 10, which is now equals to 15. So our voltage is 12, our current, which is what we are looking for, multiplied by our resistor, which is 15. So I, making I the source of formula, is our current will now become 12 over 15. So 12 divided by 15 is equals to 0.8. since we have 0.8, we have our I1 which is equals to 0.8, and we now have our I2 is equals to 1.2. So the total current is now I1 plus I2. So I1 plus I2 is 1.2 plus 0.8. So total current in this circuit is 2 amperes. So feel free to try this one. Calculate the current in the 3 ohm resistor. So to do this, we have to do something. These are connected in parallel, not in series. Why did I say they are connected in parallel? Because they have multiple ways of receiving currents. So calculate the current in 3 ohm resistor shown in the diagram above. In characteristics of currents connected in parallel, the currents that passes through different resistors are not the same. So to calculate the current that passes through 3 ohms resistor, we have to first calculate the total current in the resistor. So to do this, we have our total current to be 13. So let's recall our Ohm's law, which is V is equals to IR. So what is our voltage? We have to calculate our voltage, because voltage that passes through the parallel circuit or voltage in a parallel circuit are the same. Recall that when we are tracing our parallel circuit, we say that V is equals to V1 equals to V2 and equals to V3. So what we're going to do is to calculate our voltage, since the voltage in different resistors are the same. So to calculate this voltage, we're going to add all the 3 resistors or resistance. So to do this, let's recall our formula. Our formula is 1 over R is equals to 1 over 2 plus 1 over 3 plus 1 over 4. Why? Because they are connected in parallel. So 1 over R is now equals to the LCM of 2, 3, and 4 is 4 times 3, which is equals to 12. So 2 in 12 will give us 6, plus 3 in 12 will give us 4, plus 4 in 12 will give us 3. So we now have 6 plus 4 plus 3. So 6 plus 4 is 10, plus 3 is 13. So I now have 1 over R is equals to 13 over 12. So making R the source of formula, we now have 13R is equals to 12. So R is now equals to 12 over 13. So this is the total resistor in this circuit. So to calculate the voltage, our voltage is V is equals to what? Since they are connected in parallel, recall that voltage is equals to V1, which is equals to V, which is equals to V2, and which is equals to V3. They are all the same for parallel. So since we have our 12 volts, which is now equals to our I is what? 13. What they are also calculate? Calculate the current in 3 ohms. So we cannot use this current because they are asking us currents. So to calculate the current, we're going to just put I multiply by the 3 ohms, since they're asking us the current in 3 ohms. So making I the source of formula, we now have 12 over 3, because 3 will divide 3 and 3 will divide 3, giving us I is now equals to 12 over 3 is equals to 4 amperes. So the current passing through 3 ohms resistor is equals to 4 amperes. So in this question, let's do some things, or let's do justice to this question. So in this question, it asks us, an electric circuit is connected up as shown below. What is the value of the current through 1 ohm resistance? So they're asking us the current that pass through this 1 ohm resistance. So the current that pass through this 1 ohm resistance is, first we have to calculate the total current. And for us to do this, so calculating the total current, we have series and parallel connection in this circuit. So first we are going to do some things. We are going to add 3 plus 3 to give us 6. The reason is 3 here and these 3 here are connected in series. So since they are connected in series, we're going to add them up and it will give us 6 ohms. And 3 here and 3 in this resistor here is connected in series. So I'm going to add it up. It's going to give us 6 ohms. So redrawing this diagram, I'm going to have something like this. Here will be our 1 ohm. Here will be our 6 ohm, and here will be our 6 ohm. Reason, we have connected these to series in order for us to reduce the complex in these circuits. So since we have this now, and 6 and 6 are in parallel, so recall our formula, which is 1 over r1 plus 1 over r2. So therefore 1 over r, we're going to pick our r1 to be 6, which is 1 over 6 plus 1 over 6. So 1 over r is now equals to LCM of 6 and 6 is 6. So 6 in 6 is 1 plus 6 in 6 is 1. So I now have 2. So 2r is equals to 6. So 2 divided by 2 is equals to r is now equals to 3 ohms. So we're going to go ahead and redraw this diagram. So redrawing this diagram, we now have something that looks like this: 3 ohm and 1 ohm connected to our 12-volt battery. So we now have something like this. So since these two are now in series, so we need to go straight and add both of them. So adding both of them, we now have 3 plus 1 is now equals to what? 4 ohms. So the total or the effective resistance in this circuit is equals to 4. Since the effective resistance in this circuit is equals to 4, we have to now recall our formula to calculate the current. So V is now equals to I and R. So V is 12, I is what you are looking for, and the total resistors is 4. So I is now equals to 12 into 4 is equals to 3. So our current is equals to 3 amperes. Since our current is now equals to 3 amperes, we can go ahead and calculate what is the value of the current through 1 ohm resistor. So the value of the current through 1 ohm resistor, we are going to recall our Ohm's law. So voltage in series are always the same. So this is 12, but the currents are not the same. So 12 I and R, and ask us to calculate our current, which is I dot in our 1 ohm resistor or in our 3 ohm. So R is now equals to 4. So since the voltage is the same thing, so we're going to bring out something now. So V1 is equals to V2, which is true. So let's take our V1 to be I times 4. So current times 4 ohm resistor is equals to IR. Voltage is equals to voltage. So I times 4 is now equals to because you're looking for the current, so we're going to make this current the subject of the formula times our 1 ohm resistor, which is 1 ohms. So this is 3 times 4, which is 12, is equals to I ohms, or I. No, let me not say I ohms, or prefer using I. So since this is not equals to I, so the current passing through 1 ohm resistor is equals to 12 amperes.